Hi, my name is Dan Collier. I'm from Semantic Partners. We are a relatively young business based out of the UK. Our focus is on knowledge graphs, and I thought today what I would talk to you a bit about is what those are, how they fit in with digital twins. I understand last week Peter Winstanley from Semantic Arts was speaking to you about ontologies, so some of this stuff might be fresh, which is good. There's a bit about us on the screen there. I don't need to go into all of it, but we are set across Europe and the US. That's where we have our people, 7. We're about to have people in 8 countries, in fact, and we speak about 10 different languages. The knowledge graph community is a very international one, as you can see. So I attended the Cyber Physical Forum a week or so ago, and some of my observations from that I wanted to tie in today with really what I wanted to talk about. So from that, what I heard 2 or 3 things really that came out of that, and sort of problems and needs really from the community. The first one for that really was data sharing. So it seems that there's an issue around sharing information. How can information be shared between departments, between systems, within departments, etc. So it struck me that that's something that needed to be dealt with. Being able to show benefit early on within a program, being able to show value early on as well is something that I heard. How can you spin something up and get value out of it quickly? And the last sort of key point I noted really was projects need to be set up for scale. The Isle of Wight project, you may recognise this picture. It's the Isle of Wight. We're involved in that project at the moment, and I think that as a microcosm of what's going on, as a small project which is being set up to then scale and roll out across the UK, that's a good example of that already being in place. I wanted to talk about definitions today, really. So my observations, really, certainly related to digital twin, is that there needs to be some agreement, really, on what a digital twin is. And I mean this from a sort of our impression of what a digital twin is a digital version of a set of processes that take place in the real world. So how is that? How is there a data model built of a set of processes that occur, say, within a physical environment, a factory or a city, or it might even be a wind turbine, the operation of a wind turbine? How do you take the sensor data that's collected from that particular piece of hardware often and turn that into a data model, a digital version of that? So is that a digital twin, or is it a sort of a digital cousin or some further relation away? So anyway, my point there is that definitions are important, and I think it comes back to semantics, the name of our business, Semantic Partners. Fair data, some people may have heard about this as an expression most recently, and it comes back to the problem that we hear from the Cyber Physical Forum, which is data needs to be findable, accessible, interoperable and reusable. Interoperable, I think, is the key word there. How can data be discovered and found, reused is the key point as well. And that leads me really on to what knowledge graphs are and what a semantic data model is. So a lot of you who've been working in digital twins, a digital twin to us is really essentially a use case of a knowledge graph within a knowledge graph. Data is facts from tables to sentences. So a knowledge graph is a way of storing data in a format that the machine can understand and a human can read as well. So if you imagine your current data structures are silos, lots of essentially databases or other systems that contain your data. A knowledge graph is like a semantic layer that sits over the top that allows you to interrogate all those different data sources and dig in and actually query that data in a much more flexible manner than you would currently get from rows and tables. You might have seen my image here is a little Excel ninja. These days, unfortunately, we're still very tied to Excel and rows and columns, which gives us unfortunate rigidity in the way that we can actually query things and get useful data. So getting to that knowledge that sits inside your data is the key. A knowledge graph helps you get to the actual let's call it the gold inside your data set, right? So undoubtedly data sets are going to have a lot of information in them. How do we get them out of there? I certainly don't have enough time to go into all of it today, but suffice to say, a graph is a data model in which all the information that sits inside your data sets is turned into something like a URL. We call it an IRI or a URI. It's a resource indication. Basically, it allows to give a unique place where that data is held. You can ask questions of it. if anyone is intending to do any AI type work or try and do any kind of machine learning type work across the data sets, you really need to have a graph set up with an ontology related to it. So it's about teaching the machine the meaning of the data that sits inside it. So how do you do that? So semantics is really the it's not just meaning, but it's a way of how systems can understand and talk to each other. A common language and layer across the data sets. I don't know. I'm just looking on my time. I don't think I've got too much, have I? There's the case for semantics. These slides are available afterwards. I'm more than happy to connect with anyone if they want further information about this. But semantic modeling data in a semantic manner gives a lot more flexibility. It allows you to ask actual natural language questions of it. A lot of people may have heard about LLMs and ChatGPT and stuff. All of these rely on data being essentially readable by a machine. So if you haven't got clean data in a machine readable format, it's unlikely to be able to get any decent AI or done, if you like. But I use that term flippantly somewhat there. It's overused. I wanted to just quickly share on time-wise bit of a case study. So one of the companies we work with, we tend to work with large enterprises, but one of the organizations that have been quite vocal about their use of digital twins is Bosch. I've included this link here. I don't think you'll be able to do it from here, but maybe one of the compares can put this link in the chat afterwards because it's quite interesting. So they're looking to their manufacturing plants in Bosch. They are looking to replicate digitally all of the processes that take place in those plants. So right down to the sort of minor tasks that take place. So the way that we view that is really it's an ingestion of data sources. We create some links. We write queries to use the data in the application. So the stuff that we've been doing there. This slide describes a little bit about that, but I think the most interesting point that comes out of the work there is really as a very large organization in Europe, they are committed to semantics. They believe that there are four core pillars in which they need to build their business for the future, and one of those is semantics, and that means building digital representations and models of all of their processes and plants, in fact. So they don't have to physically go there. They can ask what if statements of what those plants might do should there be a kink in a manufacturing process or a supply chain issue, if something, if some sort of raw material is not available, etc., that kind of stuff. So I'll give you that link afterwards, but I think I'm probably on time now. I'm looking at I think I'm on about 8 minutes, so I'll wrap up there. As I say, I'm more than happy to answer any questions and go into a bit more detail. I appreciate there's not much time, so hopefully that's been a little view into potentially what knowledge graphs could do for you. Thank you.
So Dan, our first question for you, if I may, is do you have a specific example of your knowledge graph use in digital twins? Are there any solutions available in the public domain?
It's I'd like to say I could talk about the stuff that we do, but as you appreciate, most of our customers are private corporates, so it's somewhat sensitive in the amount of information I can share. The Bosch one I talked about because there's a lot of publicly available information already out there on YouTube. They were open with their commitment to semantics and their use of the graph. You can, I'm more than happy to share information in a slightly more private setting to talk about our opinions on that and some of the stuff that we've done. But other than that, I can't really say much more.
Dan, our next question is, do you not think there's enough in the standards already that provide clarification on what a digital twin is? What is missing from them in your opinion? For example, ISO 23247 and Flex 260 both already use the same language, and then I guess the DET Hub have some positions on it as well. How's that all connect in your view?
So I think the point I really wanted to raise was that I don't think there's enough agreement on language, not necessarily from a standards perspective within ISO, but from general departmental talking to one another. And that's ontologies provide a common meaning. The project we're working on at the moment is the IES 4 project, right, which is about information exchange standards. It's about driving those standards. So I think I'm not familiar with that ISO that the person referred to. I'll certainly go and take a look, but I'm sure it's adequate. I think, as I said, my observations were that everyone interprets the term digital twin too loosely, in our opinion. I think it could mean lots of different things to different people. Now, not everyone will go and look at those standards and then try and use that in their modelling or their work from that point on. So I just think there's definitions, and the use of ontologies and graphs would actually help to break down some of those barriers. Certainly the interoperability thing across departments, a knowledge graph data model would solve that.
And Dan, what is the relationship you've seen between AI and digital twins?
I think the better framing of that question might be the relationship between AI and knowledge graph. So we view a twin as a subset of a knowledge graph, as a use case, and to do AI, to use that awful expression, you really need to have your data machine readable. It needs to be structured so that systems can understand it and humans can understand it. So really, to be able to do any kind of AI, you have to have that sort of structure behind it. Now, the way that LLMs work, etc., you can do kind of LLMs, you can get natural language questions answered without having a graph, but the reliability is about 1/4 of what you would get if you had a knowledge graph structure in place to back up that ontology and the large language model.